Hi and welcome to the channel. This is today's lecture on programming fundamental. We will introducing the basic of programming. Our key subtopics includes are why learn to programming, understanding low level and high level languages, the role of diagram and flowchart in problem solving. By the end of this lecture, you will have a clear understanding of the basics and why the matter in the world of programming. Let's get started. Lecture 1. Programming teaches you how to approach problem solving logically. You learn to break down complex issues into smaller manageable tasks. When debugging code require analyzing of each part to find errors, which builds analytical skills. Programming allows you to automate repetitive tasks, increasing efficiency in both personal and professional settings. Career opportunities. Knowledge of programming opens door to numerous career in technology, finance, healthcare, and more. Creative expression. Programming is not just about problem solving. It is also about creating. You can build games, website, or apps. What is a program? A set of instructions that a computer follows to perform a specific task. Think of a program like a recipe. Just as a recipe outlines the steps needed to make a dish, a program provides step-by-step instruction for the computer archive to achieve a particular outcome. What is programming language? These languages enable to communicate with computers by giving precise instructions. Examples are C++, commonly used for system programming and game development due to its performance and control. Python, known for its simplicity and readability, widely used in data science and artificial intelligence. And Java, it is often used for Android apps development and large-scale systems due to its portability and robustness. Low-level languages are closer to the binary code, you can say machine language, that computers directly understand, making it harder for humans to read and write compared to high-level languages. Key features are they provide direct control over the hardware and system resources, which can lead to highly optimized and efficient programs. Performance, because they interact closely with the hardware, low language can execute faster and perform tasks that require precise control such as memory management and real-time systems. Example of assemblies, in this assembly code, move AX1 moves to the value A1 into the register AX, and INT TR21H calls at interpret to perform a system services. While this code is much more complex and less innovative than a higher level languages like C++ or Python, it allows the programmer to interact with the computer's CPU and and memory directly, giving them finer control over performance and behavior. High-level languages closer to natural language, just like English syntax. They abstract away the complex details of computers' hardware, allowing programmers to focus on solving problems rather than managing low-level hardware details. Ease of use, developers can write instruction in a more innovative and readable forms without needing to worry about specific like memories, addresses, or CPU instructions. Portability, programs written in high-level languages can often run on the different types of hardware with little or no modification thanks to the use of compiler and interpreter. Example in C++, the C++ code is simple and clear. It uses the standard cout command to print the text "Hello World" on the screen. This code is easy to understand because it is resemble how we express ideas in everyday languages like output this message. Importance of visual representation, visual planning. Flowchart allows us to visualize the logic and flow of program, which is essential for catching any potential problem early on. By planning ahead, we can avoid common mistakes, making the coding process much smoother. For example, imagine baking a cake. If you forget to add sugar, the cake would not turn out right. In the same way, missing steps in a program can break it. Flowchart help us plan out every necessary steps before we even start coding, ensuring we don't forget anything. Stress the visual planning helps break down complex tasks into smaller manageable pieces. Clear communication. Flow charts make it easier to communicate the program's logic to others such as the team members or non-programmers. Since they are easy to understand, they make complex process more accessible. When you have a clear flow chart, it is like having a shared languages. Even if someone doesn't understand all the technical details, they can follow the flow of the programs. This makes it easier to collaborate and get feedback early in the process. Easier debugging. When a program has an error, flowchart helps isolate the problem. Since each step is mapped out visually, and you can easily follow and flow and identity where things might have gone wrong. Say you have a flowchart for a programs that process user input. If the program fails, you can look at the flowchart and see exactly which step is not working. This makes it much easier to pinpoint and fix the problem. Flowcharts. Oval, think of oval as the start of end of your programs. Every flowchart begin and ends here. Arrow, finally, arrows guide the flow of controls from one such step to next. They show up how the program moves forward. Parallelogram input output is where data comes in or goes. For example, it might represent input from the user or the program printing a result. Rectangular process, there is a where action happens. A rectangular might represent an operation like a calculation or assigning a value to a variable. The diamonds are decisions where the program closes a path based on a condition. It's like asking a yes/no question in the middle of programs. Flowchart, start, decision, diamond, process, and they have a yes or no, and then there is an end. Example flowchart, check if a number is even or odd. So the flowchart shows the step of simple program that determine if a number is even or odd. So start the program from here, then input the number. The users input the number input. Then decision steps keep up, checks if the remainder even divided by the 2 or if divisible by 2. If yes, if the condition is true, the number is even, the program proceed to the next step. And if the condition is false, the number is it's mean odd, the program follows a different path. Print even or odd depending on the numbers you gave, and the end the program from here. The flowchart helps to clearly see the steps involved in checking whether a number is even or odd, simplifying the logic before implementation. Thank you.